All right, still on physics WAEC 2025. This is question 20. Let's see how it goes. A radioactive element of mass 60 grams was isolated and stored. It was discovered that after 40 days, only 1 gram of the element remained undecayed. Calculate the half-life of the elements. Now, this is a radioactive substance, a radioactive element. This is it is called a radioactive element because it undergoes some process of disintegration because of unstable nucleus. As a result of that, it tends to form more stable uh, nuclides. For example, examples of these radioactive elements that undergoes this decay, we have the carbon 14, we have the uranium 234. So, and the aspect of half-life that is being brought in is the time it takes for these elements to decay or to disintegrate by half of the original value. All right. For instance, maybe if you have the number of let's say the number of the nucleus of the atom is n, right? So the half-life of this the half-life, the first half-life of this will be n over 2. That is half uh of the original value. Okay, the time taken for half of the original value of the radioactive substance, any that is to decay. So that is what we mean by the half-life. All right. So now let's now do the solve the solution now. The radioactive element says it has mass of 16, right? The mass is 16. We are not interested with the radioactive elements, right? But we are interested with the value given. And after 40 days, the thing remains to what? To 1 gram. All right. What is the half-life of the elements? Okay, now let's start with 16. Now, I told you that what half-life is has to do with half the time taken for for radioactive substance elements to decay, to disintegrate, to break down, to split by half of the original value. What is the original value of this radioactive element? Is 16. All right. Now, the half-life of this one, the first half-life of this one, that will be half of this will be what? Will be 8 gram, which is that's the first half-life of this radioactive element. Now, another another half-life will take place because it is still unstable. So it will now be what? Half of 8, that will be 4 gram. That is half second half-life. Okay. So the next one is still what? By half again. That will be 2 gram. That will be third half-life. Then another half-life will take place again, which is which will give you 1 gram of this, which is fourth half-life. Okay, right. So because it only remains 1 gram, so consider it takes like fourth half-life for it to what disintegrated to uh for it to disintegrate to 1 gram. So now after 40 days, now that means that 4 half-life, okay, is equal to 40 days. 4 half-life. So what will be the 1 half-life? The half-life, that will be divided by 4. Okay, divided by 4, and that will give us 10 uh 10 days. So the half-life of this redundant substance is 10 days. That is, after every 10 days, each 10 days, the mass will be disintegrate, break down by half of the original value. If we can check. Let's say the first 10 days, it breaks to what? It breaks down to 8 grams. Another 10 days, it breaks down to what? 4 grams. Another 10 days, 10 days, it breaks down to what? 2 grams. Another 10 days, it breaks down to what? To 1 gram. So calculate the number of days now. That will be 1, 2, 3, 4, which is 40 days to reach 1 gram. So that is how it is calculated. Now, if you find it useful, don't forget to share, to like, and to follow this channel. Thank you.